So this video is looking at the Highen method for calculations based on equation, the three-step method where we consider step 1, the tick side moles, step 2, the mole to mole ratio, and step 3 is calculating the question mark. So when we look at the question here, we have to calculate the mass of water. So we'll calculate the mass of water as our question mark when we burn 48 grams of methane. So we have 48 grams of methane. So I'm going to narrow my focus here and I'm going to take my methane to my water. And then I'm going to write my mole to mole ratio. So 1 mole to 2 mole. Now at this point at National 5 you would work through your mass to mass ratio, but we're going to do a different process here where again we've got our tick side here and we've got our question mark here. Step number 1 is always to go to the tick side and calculate the number of moles. So step number 1 is the tick mole. So I take my CH4 and to work out number of moles, N equals M over GFM. My GFM, I have 1 carbon, which is 12, and I have 4 hydrogens, which is 1, so my GFM is 16 grams. So my mass from the question is 48, so I take my 48, I divide it with my GFM, which is 16, and that gives me 3 moles. Step number 2 in the Highen method is to take this number of moles back to the theoretical mole to mole ratio that I have from the balanced equation. So step number 2 is now to calculate my mole ratio. So I've got a 1 to 2 ratio, so for every 1 mole of methane that I burn, I produce double that, 2 moles of water. But I don't have 1 mole, I've calculated that I've burned 3 moles. So I take my 3 moles here, and then I'll look at my ratio. I've got 1 to 2. Therefore, I have to double this, so times 2. So when I've burned 3 moles of methane, I've produced 6 moles of water. The last step in this process is step number 3, and step number 3 goes right back to the question mark. What was I asked to calculate? And I was asked to calculate the mass of water. So M equals N times GFM. So I have water this time. And I look for my GFM of water. So I've got 1 oxygen at 16, 2 hydrogens at 1. So my GFM of water is 18 grams. I then put that into my equation. So I've calculated here that I've got 6 moles of water. My GFM is 18. 6 times 18 gives me 108 grams. So a 3-step process here. 1, calculate the tick number of moles. 2, take that back to get a balanced mole to mole ratio, and then 3, calculate my tick side. Now that's an example of a mass to mass question. I'm going to give you another example now where we use the NCV triangle as well. So if we look at this example here. In this example, we have to calculate the mass of MgCl2. So again, I've got my question mark here. When I use 500 cubic centimetres of 0.5 mole per litre HCl, so my tick is here. Again, I'm going to narrow my focus, so I have 2 HCl to MgCl2. Tick and question mark. Again, put down my mole to mole ratio based on the balanced equation, so I've got a 2 mole to 1 mole ratio. Step number 1 is the tick number moles, so tick, mole. I'm using HCl, so I take my HCl over to the side and I look at the information I have about HCl. I'm trying to work out number of moles, but look, I have a concentration and a volume here, so I'm going to be C times V this time. Now my concentration is 0.5 and my volume, although it's 500 cubic centimetres, remember, I need to change that into litres, so divide by 1,000. So my volume is also 0.5. So concentration 0.5 multiplied by volume 0.5. So I have a number of moles of 0.25 moles. Step number 2 is to do my mole ratio. So step number 2, mole ratio. So based on the fact that in my balanced equation I've got a 2:1, I take my 0.25 moles up here and write it in there. Therefore, I'm working out from this relationship how many moles of magnesium chloride I've made. So I've got 0.25, I've got a 2:1, so I only produce half of the MgCl compared to what I use of HCl. So for this one here, I'm dividing my number by 2. So I end up with 0.125 moles of MgCl2. Step number 3 is my question mark. What am I being asked to calculate? Back to the question, I've been asked to calculate the mass of MgCl2, which again, back to my N times GFM triangle. Then I have to take my formula for MgCl2, put it in my bubble and work out my GFM. So I've got 24.3 and I've got 2 times 35.5. So my GFM for MgCl2 is 95.3. So when I plonk this in, 0.125 times 95.3, and my answer is 11.9 grams. So this is the higher method for calculations based on equations, and it's a 3-step process. So I start off the same, get my tick in my question mark, narrow my focus, tick, question mark. Put in my theoretical mole-to-mole ratio based on the big numbers in the balanced equation. Then, step number 1, tick side, calculate the number of moles. Use whatever relationship you have the information for. So it's either going to be NCV or M over GFM. Step number 2, once I've calculated my number of moles, take it back up to the theoretical mole-to-mole ratio and work out what my actual mole-to-mole ratio is. And step number 3, now that I've got my number of moles, I now look at what the question mark asked me to calculate. In this case, it was mass, so I use the number of moles I've calculated and then multiply by my GFM.